Hello, statistics students. Here's another video on the basic ingredients for testing with categorical variables. This video covers the details of the chi-square test, part 1. So let's look at the data. Recall that categorical variables are those whose values are categories as opposed to numbers. The outcome of the roll of a die can be thought of as a category, particularly if we don't care about the numerical values on the die. It could be labeled A, B, C, D, E, and F. It would be equivalent. When two categorical variables are analyzed, as we're doing in this chapter, they are often displayed in a contingency table, also called a two-way table, a summary table that displays frequencies for the outcomes. Such tables can give the impression that the data are numerical because you're seeing numbers in the table, but it's important to keep in mind that the numbers are summaries of variables whose values are categories. For instance, the General Social Survey asked respondents, there are always some people whose ideas are considered bad or dangerous by other people. For instance, somebody who's against churches and religion. If such a person wanted to make a speech in your city, town, community against churches and religion, should he be allowed to speak or not? These respondents were also asked about their income, which was recorded as one of 4 income levels, 0 to 20,000, 20 to 40,000, 40 to 70,000, and 70,000 and more. The first 4 lines of the actual data would look something like Table 10.2. The first 4 lines of the actual data would look something like I just showed. So observation ID 1 is the first person, second person, third person, fourth person, and so on. So the first person was allowed to speak with an income level of 20 to 40,000. Second person was allowed to speak with an income level of 20, 40,000. And the third person was not allowed to speak, and they had an income level of 70,000 and over. Just for the sake of for the design here, a value on the boundary would be assigned to the group with smaller income. So if you had an income of 40,000, you'd be placed in the 20 to 40,000 category. A two-way table summarizes the association between the two variables, response and income level. So of the 0 to 20,000 income level earners, 248 were allowed to speak and 100 were not. Of the 20 to 40,000 income level earners, 311 were allowed and 105 were not allowed, and so on. Now keep in mind with a two-way table, we will typically have to come up with all of the column totals. And then also you have to do your row columns. I should say row sums as well. That was 250. The row of number allowed to speak is 1,011. And the total number of not allowed is 281. You add the total 1,011 to 281, and you get 1,292. And you add the 348 to 416 to 278 to 250 and get 1,292. Because we're going to need the total of all of these contingents. These are called your contingency rows and columns. All right, so now let's shift gears to expected counts. This is what's new with the chi-square test. The expected counts are the numbers of observations we would see in each cell of the summary table if the null hypothesis were true. A little later, we'll set up some formal hypothesis tests, and you'll see more precisely how to calculate the expected counts. For example, table 10.1 shows the actual counts we observed when we rolled a 6-sided die 60 times. If the die were truly fair, then because each outcome would have the same probability, we would see the same number of outcomes in each category. When the die is rolled 60 times, the expected counts are therefore 10 in each outcome category. That's because each respective probability for the category is 1 out of 6. We expect 1 out of 6 of the total outcome. So we had 60. 1/6 of 60 is 10. Table 10.4 compares these expected counts with our actual accounts. So in table 10.1, we saw observed accounts, and the expected accounts should be 10. Looking at a different example, slightly more complex, but still quite typical, just consider a study of the link between TV viewing and violent behavior. Researchers examined TV viewing habits for children, comparing children who watched TV programs with a high level of violence with those who didn't watch it with a high level of violence. Many years later, they interviewed the same respondents, now they're adults though, about violent behavior in their personal lives. And table 10.5 summarizes the results. So children who watched high TV violence while younger, 25 out of the total 329 respondents stated that there was physical abuse in their personal lives. And 41 who watched high TV violence said there was no physical abuse. Whereas low TV violence, 57 of those did have some physical abuse in their personal lives. And of the low TV violence watching children, 206 out of the 329 said that there wasn't any physical abuse in their personal lives as adults. So there are two categorical variables: TV violence, high, TV violence, low, and physical abuse. Physical abuse, yes. Physical abuse, no. The subjects were asked whether they had pushed, grabbed, or shoved their partner. We wish to know whether these variables are associated. The null hypothesis says that they're not, that these variables are independent. In other words, any patterns you might see are purely due to chance. What counts should we expect if these variables are truly not related to each other? That is, if the null hypothesis is true. What would we expect the table to look like? There are two ways of answering this question. They both lead to the same answer. And this will help us generate a formula to understand how these are calculated. So let's look at both of these. So the first one is going to be starting with the physical abuse variable. And the next one, the second one, is going to be looking at the TV violence variable. And again, we'll see that we obtain the same results. We notice that out of our entire sample, the 329 total respondents, 82 out of 329, 82 out of 329 said they had physical abuse, or said they had physically abused their partners. If abuse is independent of TV watching, that is, if there's no relationship between these two variables, then we should expect to find the same percentages of violent abuse in those who watched high TV violence and those who watched low TV violence. So when we consider the 66 people who watched high TV violence as children, we expect 24.92% of them to have abused their partners. So this translates into 24.92% of that 66, but we're using this number, 82 divided by 329.249240 times 66 is 16.4498 people. So if there was no association with the variables, we would expect to have 16.4498 people who watched high TV violence as children to have abused their partners. When we consider the 263 low TV watching violence, low violence watching we would expect to find that 24.92% of those, or 0.249240 times 263, or 65.55001 of them to have abused their partners. So if these variables are not associated, the count would be 65.5501 of the low TV violence watching to have abused their partners. Now we can use similar reasoning to find the other expected counts of those who did not abuse their partners. So we know by our table that 82 out of 329, or the 0.249240, abused, had physical abuse. 247 out of 329, or 1 minus 0.249240, equals 0.750760, to have not abused their partners. This proportion should be the same no matter which level of TV violence was watched, assuming the null hypothesis is true, assuming there's no association. So thus we expect the following to happen. In the no physical abuse and low and high TV violence group, .750760 times 66 is 49.5502. In the no physical abuse and low TV violence group, we would get an expected value of, or a count of, 197.4499. And we're avoiding rounding in these intermediate steps so that our answers for the expected counts will be as accurate as possible. So let's take these counts, 16.4498, 65.5501, 49.5502, and 197.4499, and let's arrange them into the table 10.6. This shows the expected counts if there's no association in parentheses. and we include the actual accounts in the table so that we can compare. So we expected that if there was no association, 16.4498 people, which is rounded here to 16.45, would have abuse if they watched high TV violence. So to display a formula for this, the row totals are 82 and 247, and the column totals are 66 and 263, giving us the grand total of 329. And so let's go back and remind ourselves how we calculated this 16.4498. We started off with 83 over 129. Sorry, 82 over 329. And then we multiplied that by 66. So for this entry, the 16.45 from the physical abuse, high TV violence, we took the row total of 82, multiplied it by the column total of 66, and divided by the grand total of 329. So this is how those expected counts for each cell are calculated. Now, as stated earlier, there's two ways of answering these expected counts question, and they both lead to the same answer. The first one was looking at physical abuse variable, and now we'll shift to doing the same thing with the TV violence variable. The other way of finding expected counts is to begin by considering the TV violence variable rather than beginning with the physical abuse variable. So we see that 66 out of the 329, or about 20.06%, watched high TV violence. The rest, 263 out of 329, watched low TV violence. If these variables are not related, then we look at the 82 people who committed physical abuse. We should expect 20.06% of them to fall in the high TV violence category and the rest to fall in the low TV violence category. Also, when we look at the 247 who did not commit physical abuse, we should expect 20.06% of them to have viewed high TV violence. Among the abusive, the expected number with high TV violence then is about 20.06% of the 82, which is 16.45, which is what we got before. Among the non-abusive, the expected number with high TV violence is 0.200608 times the 247, which is 49.55, which is what we calculated the other way. So you'll see that you get the same result no matter which variable you consider first, and then that's exactly why we use this formula to come up with expected counts. And this concludes this video on the details of the chi-square test, part 1. In the next video, I'll go over the other details for the details of the chi-square test.